All right, in this video, we're going to get an introduction to optimization. So what is optimization? It's essentially the same thing we've already been doing with functions in the XY plane when we're finding extrema. We did this on our last test. What's the difference? Well, the context. Instead of just having any old function f of x or g of x or whatever, all of our functions are going to represent things like costs, profit, area, volume. And our goal is to find the minimum amount or maximum amount of any of those things. So let's say we have this graph right here. Usually we would have called this thing y equals f of x, but we're going to give it a name, say p of x or q of x, whatever, where that function is going to tell us, again, something like costs, profit, area, volume. It'll tell us some measurement of some actual thing we're trying to find the extrema for. And we call that optimizing. So looking at that graph right there, we can kind of tell that we're really only looking between, say, like 0 and 4 on the x-axis. So we have a name for these things. The function that we're looking at the mins and maxes for, we call that our objective function, because our objective is to minimize or maximize that. And then given any sort of requirements or restrictions on, say, the inputs or the outputs, we call those things constraints. So find the min or the max of this function given certain restrictions on, in this example, an x value or set of x values. So what's our overall process? Well, first thing you want to do, you need to carefully read everything because they will give you all of the information that you need, sometimes more than you need, but you need to read it all. Next, you want to use any formulas that you've seen in geometry, algebra, any of that. We need to come up with that objective function. They're not going to give that to us. That's usually going to be the hardest part, figuring out what is the function that I'm supposed to optimize. You also want to clearly define what your variables are so that you know what any restrictions might be, meaning we can then list our constraints. Then you're going to use calculus. You'll find either by the first derivative test or extreme value theorem what the extrema are going to be. And then you also always want to clearly state what your final answer is going to be. So as a quick example, this is a really common one. I call this the fence problem. Say that we have 750 feet of fence that we're making a rectangular fence out of along a pre-existing wall, meaning we don't need to put fence along that wall. We're supposed to figure out the dimensions of that rectangular fence that will give us the most area inside of that fenced region. So this is something you likely saw in pre-calculus and you probably solved using your graphing calculator, but now we can find those extrema using first derivative test or extreme value theorem. So let's carefully look at some of these details. That 750 feet, that is fixed. I can't get any more fence than that. I might be able to use less, but I don't have any more fence. Also, the shape of my region is rectangular. That's important because a rectangle has a different area formula than, say, a triangle or anything else. Also, another thing, I don't need to make a fence along the required or the pre-existing wall. There's no fence required along that. So let's kind of visualize what's happening. I've got a wall, and then with 750 feet, I need to make a rectangular fence that is connected to that wall. So let's clearly define a couple things. You have a lot of options. I'm going to start off saying x is the length of this of the fence opposite to that wall. So that would be x amount. Now I have 750 feet to use. If I use up x amount, I have 750 minus x left over for the other two sides. Since this is a rectangle, those two sides are also the same length. So to get each one, I could divide that by 2. So 750 minus x, all divided by 2. So I know that all of that has to add up to 750. If you actually add those expressions together, you're going to get 750. Now, I need to maximize the area. So my area formula is typically base times height. Before I do that, though, it might be a good idea to look at what could I use as x. I know that x can't be a 0, or I should say, shouldn't be less than 0, because x is a length. So the minimum amount of x I could have is 0. The maximum I can have is 750 because the total amount of fencing I have to work with is 750. So that is my constraint that I'm working with. My objective function is area function. So that's base times height. Looking at the way that I drew my picture here, I could use a base of x and a height of 750 minus x over 2. So this right here is my objective function. I want to do all the calculus with that. So looking at that function, I can do a little bit of algebra, pull that 1/2 out. I can also distribute. I haven't done any calculus yet, but I made the calculus a little bit easier because as it was written here, I'd have to do a product rule. I don't want to do that. So instead I can distribute. Now when I find my derivative, things are rather simple. And then when I set that derivative equal to 0 to find my critical numbers, it looks like I get 375. Notice that 375 is between 0 and 750. That's important. If I was to get a critical number that was, say, 800 or -12, I would throw that thing out. I wouldn't need to check it because that is not within the acceptable range of this problem. So now I'm just going to make a chart. I'll look at when x is 0, when it's 750, and when it's 375. Looks like I get a maximum of 70,000 and some change. So I chose to use the extreme value theorem because if I have endpoints, I can plug in those endpoints and then compare that with plugging in any critical numbers. Sometimes you don't have an interval. Sometimes you have to just do the first derivative test. Every problem is just a little bit different. So it looks like clearly having 375 as the length opposite of the wall is going to give me the most area there. So I would figure out what the other two sides have to be. So if you work that out, you should get 187.5 because 750 minus 375, take that and divide by 2. So my final answer should be written nice and coherent like this. These are the dimensions that give me this maximum area there. That should give you more than enough to get started on those questions on Schoology.